We have introduced 5 design patterns for concurrency in programming. Among these 5 patterns, I think the most widely used pattern is the future pattern. However, that's probably also the most hard to understand one. The good news is that as long as you know how to do online shopping, it's easy for you to understand what the future pattern is. So in this video, I'm going to use the online shopping analogy to walk you through what the future pattern is and how to use it. I guarantee that by the end of this video, you will just get it. So we said we will use the online shopping analogy. So let's recall what we actually do when we do online shopping. Say if you want to buy a mouse, you need to put an order, right? So what do you put in the order? 2 critical things. Number 1, what do you want to buy? Mouse. Number 2, where do you want Amazon to send the mouse to? The deliver address, right? No, the money is not relevant here. So where and what? These 2 things. Remember this. Then you put your order and you don't wait Amazon to finish its job, but you continue your other tasks. You watch movie, you listen to music. And meanwhile, Amazon is preparing your package, and based on the address you provide, they deliver the package. So when you come home, you see the package and you pick up it. That's the end of the story. There are a few key things happening in this process that mirror the key concepts of the future design pattern. Number 1, you are the calling thread or the consumer thread in the design pattern language, and Amazon is the producer thread or the thread that provides the service. Amazon lives in another thread that's different than your thread is because you do not want Amazon block your thread. After you send the order, you want to continue your life. You don't want to wait for Amazon, right? So that's why you and Amazon live in 2 separate threads. Second, the order. In the design pattern language, it is a promise. You put an order, you create a promise. Even though you create the order is for Amazon. Same thing to promise. Even though the calling thread creates the promise is mainly for the producer thread, the Amazon thread. Once the calling thread creates the promise, you just continue to do other stuff. And the producer thread, the Amazon thread, gets the promise, it starts doing its job. And once it's finished, it based on the return address in the promise, it actually puts the result into that address so that you, the calling thread, can get the result. Now you understand the pattern, but let's use code to tell the story again. So here is our code. So the main function is the calling thread. It's you. So you create a promise, you put an order, you create a promise. And remember, one important thing in the promise is the delivery address. That's why we call the getFuture function to get the delivery address. So future here is the delivery address. And also remember that even though the calling thread creates the promise is mainly for the producer thread. That's why when we create the producer thread, we pass the promise to this thread, in which it's called the do long work. It just do its work, just like Amazon. It prepares the package for you. There's a slight difference than the real world story. In the real world story, we tell Amazon what to do through the order. But here, when we do coding, we just call the function within that thread directly. We don't rely on the promise to tell the thread what to do. But we still need to return the results, right? And that's why we called promise set value and set the value to the result. Just like the order in the real world, the order itself doesn't get a package. It merely provides the information where to deliver the package. So promise doesn't store the value. Promise merely tells the program where to store the value, the result. So in this case, the result is not stored in the promise, but stored in the future. The thread finishes work when you come back, you see the package at your front door, right? So your front door is the delivery address. So in our code, the future is the delivery address. So you call the get function, you get the results. End of the story. So that's it. It is this simple. So the future design pattern is actually very simple. Instead of creating a promise, get a future and manually create a thread and pass a promise. C++ provides a function called async, where you can do all these three things in one line. Here's the code. So you have the async, and you just, within this function, you just use a lambda code to do whatever you want, and then return the result. Then you, in the future, you just get the result. The async function return the future for you. You don't need to manually call the get future function. And you will notice that there's a first parameter that defines the async policy. So basically it has two options, the async option and the deferred option. The async option creates the thread immediately in this line. And the deferred option doesn't even create the thread. It actually get executed when you call the get function. For more details, now we have ChatGPT. We don't have to spend time explaining those details here, right? As usual, we put the source code into our chat group, and the link is down below the video, or you can use a QR code to enter the group, where you can find the materials for all our past videos. And thanks.